Hi everyone. So right now we will talk about wave interference. So in order to understand Young's double slit experiment, Young's single slit experiment, diffraction grating, and all sorts of stuff, we need to understand interference of wave really well. What happens in constructive interference and what happens in destructive interference. We know by definition that in constructive interference, two waves which are in phase, their amplitudes add up and give us a bigger wave. Okay, and in destructive, what happens is crest and troughs, they overlap, and what happens is a destructive wave happens. So let's visualize it and let's do some mathematics behind it, so that we can build onto our Young's double slit, single slit experiments. Okay, because all the calculation that we have to do in those Young's experiment and diffraction grating, the basics for that is basically constructive and destructive interference. If you understand that well, then you will be able to understand everything that is going on in Young's experiments and diffraction grating. Okay, I will go to Desmos and I will basically start a different demo. So let's start with I have a wave. Okay, let's start with I have a wave. Okay, so now I want to let's bring in another wave. Okay, I have two waves now, so I want to overlap them. Right now they are in phase. Both of them are sine waves. Both of them are in phase, which means if I overlap them, they will exactly go over here. When that happens, what is happening right now is they are in phase right now. Okay, the displacement at every single point is exactly the same. What principle of superposition says that when two waves interfere, their displacements at any given point adds up. So at this particular point, the displacement is one box, right? Which means my interference will cause a constructive wave, which will have a displacement at this point equals to 2 box width. At this point, or maybe at this point, it is 2 box long, one wave. Since we have two waves, that means 2 plus 2, 4 box long. I will get another wave which is 4 box long. So I will get some type of this wave if I join both of them like this. Okay, if I join both of them like this, I will get a constructive wave. Now let's move one wave forward. You see what is happening? What I will do is I will get rid of constructive wave right now. Let's move it. First of all, they are in sync right now. Let's move it forward. I will keep on moving. How much did I moved forward? I moved just half a wavelength forward. And what happens? You see an all out of phase waves. Out of phase means the crest of one and the trough of the other one, they are aligning. What would happen? This displacement is plus 2 boxes. This displacement is minus 2 boxes. They will add up. And what would be my displacement wave look like? The black wave, you can see in the middle, it is exactly straight line. So destructive interference happens. Okay, destructive interference happens. Now let's move another half wave forward. So let's move another half wave forward. Now how many wavelengths I have moved forward? Previously I moved half wavelength, and now again I have moved half wavelength. So total of 1 wavelength. When I move 1 wavelength forward, in the situation when my original 2 waves, they were in phase, and I move 1 wave forward, what happened? Exactly the same thing. Now my resultant wave, the constructive interference will happen. It will have double the amplitude. Okay, as you can see. Okay, Now let's move another halfway forward. Let's move another halfway forward. Right now, so far, in total, I have moved 1.5 waves forward. 1.5 wavelengths forward. Okay. What do you see? The destructive interference again appears. So what do we understand in this particular scenario? We understood one thing, that if the original two waves, they were in phase, in order to have a constructive interference, they have to move forward in multiples of lambda wavelength, right? You see, if I move another halfway forward, I will have another constructive interference. Okay, I will have another constructive interference. Let's see all of it together in slow motion and see what is happening. As the wave is moving forward, look at the black wave. Okay, as the blue wave is moving forward, look at the black wave. It is going up and it is going down, flat line, then it is going to the maximum amplitude, and then it is going to the flat line. So this is what is happening. Okay, so which means we understood one thing, that whenever, for example, this is my starting wave, I moved it half wavelength forward, constructive interference. Complete wavelength forward, constructive interference. 1.5 wavelength forward, destructive. 2 wavelength forward, again constructive. 2.5 wavelength forward, destructive. And 3 wavelength forward, again constructive, which means the constructive interference will happen whenever my wave will move forward or backward in multiples of lambda. 1 lambda, 2 lambda, 3 lambda, 4 lambda, then I will be having constructive interference. And similarly, if I am moving half wavelengths forward or backward, then I will be having, for example, half lambda, 1.5 lambda, 2.5 lambda, 3.5 lambda, then I will be having destructive interference. So this phenomena is something very important. Understanding that what wavelength if I travel, then I will get constructive interference is very important. And keep in mind, originally our original waves, they were in phase. Then this is the criteria. When the original two waves, they are in phase, then they have to follow this rule, in which they have to move in multiples of wavelength in order to have constructive interference, and they have to move forward in half wavelengths in order to have destructive interference. Okay, 0.5, 1.5, 2.5, then destructive. But what happens if the two waves originally were 180 degree out of phase, or let's say pi out of phase? Okay, so let's look at that. Let's look at now two waves which are originally out of phase. Okay, so let's bring in another wave. So I have another wave. Okay, so the red wave is my sine wave originally, and now I got a cos wave. Okay, a cosine wave. Now what I will do is I will overlap it. Let's overlap it. Okay, so when I overlap it, what do I see? What do I see? I think one of my variable is wrong, so let me adjust it. Okay, so I don't think I need a cos wave. What I did is I brought in a wave which is out of phase, 180 degree out of phase, which means I brought a sine wave which is reflected on x-axis. Okay, so now if I bring it and overlap it, you can see that right now what is happening, my waves should be destructively interfering, right? My waves should be destructively interfering. So let's look at the wave for the interference. So I just plotted it. You see the blue line? it is the destructive interference. Okay, so now let's start moving my one wave forward and see what happens. Let's move it one or maybe half wavelength forward. Let's move this forward. Once I moved it half wavelength forward, you see what happened? You see what happened? Okay, so we are back, and now I have two waves, right? You can see that we have two waves, and both of them are right now out of phase, 180 degree out of phase. Okay, or you can say pi degree or pi radian out of phase. Okay, so now what I will do is I will move this wave half wavelength forward. Let's see what happens. When I move it half wavelength forward, what happens? Now it is in constructive interference. If I make the constructive line, it looks something like this. Okay, so what happened to my, okay, yep. I think my constructive line is, okay, so I have finally figured it out, and there was some error in my graph. So now you can see that two waves which are overlapping, and they are 180 degree out of phase. As you can see, I have changed my axis as well, because that's what was getting wrong here. And so now let's see, if I start moving my wave forward. Okay, so let's move it 180 degree forward. When I move it 180 degree forward, it is overlapping, and you can see that the amplitude is adding up. Okay, as I move another half wave forward, now I have completed what? One complete wave. Previously, when they were in sync, when I was moving one wave forward, we were having constructive interference, and now when I'm moving one wave forward, I'm having destructive interference. Whereas when I moved half wave forward, I had constructive interference. So it's very important to see what is the starting point, what is the phase difference of the original waves at the starting point, and that's how we can determine when we would be getting the constructive interference and when we would be getting the destructive interference. Let's do some calculations on that. Okay, so let's do some calculations on that. Let's go back to my slides, and where I will be doing some annotations, and we will do some calculations. So now you can see that I have a wave. Okay, let's bring in another wave over here. Okay, so I have another wave. Okay, so what I want to do is I can move this wave up and I can overlap. When I overlap, I can see that they are overlapping right now. Okay, but let's move it one wave forward. As I'm moving it one wave forward, you can see that I just moved it one wave forward. You can see that what is the difference here? What is the distance I have covered here from this particular point? Okay, from this particular point till this particular point, it is one complete wavelength. It is one complete wavelength. Okay, so let's move another wave forward. So let's move another wave forward. So I just moved another wave forward. Right now it is still in it is still doing constructive interference. Okay, so what wave I have moved forward from this point to this point? What is the distance I have covered? The distance is again one wavelength. I will keep on doing that, and it will keep on happening. Whereas let's move it back from the original position. Let's move it just half a wave forward. Okay, why do I know, or how do I know it is halfway forward? Let's see. So what is the distance I have moved from this point This is the starting point, let's say, and this point. So this is technically lambda by 2, right? And you can see that there is destructive interference is happening. Okay, there is destructive interference is happening. So if I want to plot the overall constructive interference or destructive interference, I can see that if, for example, if I move my wave forward, okay, one wavelength, what would happen? Here these two waves are overlapping. Here these two waves are overlapping, which means at this particular point my amplitude would be doubled up. So I will be getting a point at this point. At this point, obviously both are 0, I'll be getting 0. At this point I'll be getting the double the amplitude. At this point, here again 0, here again the double point, here again 0, here again the double point. That means my wave will look something like this, like a cos wave which has the amplitude of it has been doubled. And I can keep on making that. Okay, so we can see that according to the principle of superposition, we can see that the amplitude is adding up. Okay, how much I move forward? One wavelength. When the two original waves were in phase. Okay, then in order to have a constructive interference, the distance, for example, how much distance this particular wave has traveled and how much distance this particular wave has traveled, let's talk about it. Okay, so let's talk about it. What I'll do is I'll open up another. Okay, so now see, these waves are overlapping. Let's move it one wave forward. Okay, now tell me one thing. How much the first wave is moving? So this wave is moving what length? From this point till this point, let's say. Okay, how far this wave is moving? This wave is covering what distance? This wave is covering technically more distance than the other wave, right? So let's make the length from this particular point. So this wave is covering more distance. So what is the difference between these two distances? So let's say this distance is x1 and this distance is x2. What is the path difference? That path difference for constructive interference is lambda, right? But what it would be for destructive interference? It would be lambda by 2, right? So for example, it will be overlapping when the path difference was 0 first. Okay, so let's call this path difference as delta x. Okay, so let's call this delta x. So delta x, when it will be 0, then I will have constructive interference. When it will be equals to lambda, then I will have constructive interference. When it will be equals to 2 lambda, then it will have constructive interference. When it will have 3 lambda, and so on. So it is whole number multiple of lambda. Okay, or I can say n lambda. What about, so this will give me constructive interference. So if the path length is, for example, lambda by 2, then I will have a destructive interference. What about the next one? It will be 1.5 lambda by 2 or 3 lambda by 2. Then it will be what? 2.5 lambda by 2. 5 over 2 lambda. And then it should be 2.5 lambda. 5 over 2 lambda, and so on, which means I'm getting n by 2 lambda multiples whenever I have this multiple, and this delta x is in this form, n over 2 lambda, then I will have destructive interference. So we have exactly the opposite thing when the two phases were originally not in phase. So I will write it, when original waves are originally two waves are in phase. Okay, now if two waves originally are 180 degree out of phase, then delta x would be equals to 0, pi, 2 pi, 3 pi, and so on, n pi. This path difference would give me destructive interference, whereas path length of half wavelengths would give me constructive interference. So this is what we need to remember, and this is what we need to know. If the original waves are in phase, then what? And if they are not in phase, out of phase, 180 degree, how much out of phase? That's what depends. Right now, if it is 180, then we will have maximum destructive interference or maximum constructive interference. But in other cases, it will be maybe not maximum, but some sort of excuse me, destructive and some sort of constructive interference. So this is a very key important thing that we need to remember. Okay.